So this video will cover 2.2 and 2.3, which is solving inequalities by adding or subtracting, and 2.3 discusses solving inequalities by multiplying or dividing. So we're going to move kind of briskly through here. Basically, the gist of this is that when you are graphing inequalities, when you are solving inequalities, you do the same exact thing as solving equations. So, for example, if I said to you x plus 8 is equal to -5, in order to solve this, you would normally subtract 8 on both sides, and you would get x is equal to -13. The difference with inequalities is that now instead of an equal sign, we're using symbols, of which they could be any of those four. The inequality might look something like this. If this said less than or equal to, then as you continue solving as normal, you treat the inequality as if it was the equal sign. You just make sure you rewrite that inequality symbol. So in this case, that question, x plus 8 is less than or equal to -5, you minus 8, you get x is less than or equal to -13, which, if this is 0 and this is -13, it's a closed circle shaded to the left. And that would be your solution. So it's the same exact concept as when you solve equations. So let's do these questions quickly so that you guys could pause it and then try them. Notice that here they give you three different things. They want you to solve the inequality, graph the inequality, and then write it in set builder notation. So let me show you what that means. Solve the inequality. Well, if my inequality is a minus 42 has to be greater than -64, if I treated the inequality as if it was the equal sign, and I continue to solve like normal, I would remember that I have to unsubtract, which means you add, and you get a is greater than. Now please be careful here. The majority of issues that we have with this is that people write equals because they're used to it. Okay, and then we continue here. -64 plus 42 is -22. The graph would look like this. If this is 0 and this is +22, -22 is to the left. It's greater than, so it's not or equal to. So greater than means it's an open circle. But it says it's greater, which means that it shades to the right. And again, the reason it's an open circle is because there's no underline. And you shade to the right because it's greater than. So this is what yours would look like. Set builder notation is simply writing it like this. The values of x, or in this case it's a, so the values of a, such that a is greater than -22. That's the set builder notation. For the next question, we have -8 is greater than p plus 15. Solve like you normally do. -15 again. This is what separates both sides of the equals or of the inequality, that symbol. -15 minus 15. -8 minus 15 is -23 is greater than p, which written properly, remember to flip it so the letter's on the left. P is less than -23. Graph, number line. If this is 0 and this is -23, this is +23. Less than, not or equal to, is just less than -23, so it does not include -23, it's an open circle, and less than shades to the left. Set builder, the values of p such that p is less than -23, closed circle. Closed set builder notation. So this was adding and subtracting. Let's look at some word problems. Remember that word problems with inequalities, there's certain words that mean certain things, like at least, at most, no more than, those types of words. So look for those words when you're reading, although the most important thing is to read for yourself, to tell yourself a story. Ellen has 150 to spend at the mall. She purchases, so she actually buys, a CD for $16.99, a shirt for $41.99, and lunch for $5.25. She still wants to purchase a pair of shoes. What amount can she spend on the shoes? So we know that the amount of money, let's say S is for spend. So we're going to write down that the letter S, or the variable S, represents, let's say N, because S looks like a 5. N is the amount of money that she can spend, or that she can use on shoes. And we know that the amount of money she can spend at the store for shoes has to be, the total amount has to be less than or exactly equal to $150. Now, if we took tax into account, then it would just be less than, because you got to make sure that you have enough. But it's less than, because the amount of money you have to spend is $150. That means you have to spend less than or equal to $150. So that amount that she totally spends has to be less than or equal to $150. She has N for the amount of money she's going to spend on shoes, plus the amount of money she spent on a CD, plus the amount of money she spent on a shirt, plus the amount of money she spent on lunch. If we simplify this, we know that the amount of money she can spend on shoes plus the total amount that she has spent so far, which if you add it all up, $16.99 plus $41.99 plus $5.25, $64.23. That amount together, the amount she spends on shoes plus the amount she already spends, has to be less than or equal to $150. Now we solve our inequality. N, the amount of money she can spend on shoes, has to be less than or equal to $85.77. Okay, let's go to the next one. Miss Lawrence wants to buy an antique bracelet at an auction. She's willing to bid no more than. Okay, so as we see that she's willing to bid no more than, we know that the amount she wants to bid, B is for bid, the total amount has to be less than or equal to $550. So far, the highest bid is $475. Write and solve an inequality to determine the amount that she can add to the bid. Well, if she wants to add the amount that she can bid to the $475, we know that the amount she's going to add to it, so B could be the amount added to the bid. The amount she adds plus the $475 that it's added right already has to be less than or equal to $550. Again, treat this like if it was the equal sign. You're going to solve by subtracting, and you're going to get 550 minus 475 is 75, so the B has to be less than or equal to 75. Okay, so this was when you're adding and subtracting. So this is one-step equation or inequalities when you're adding or subtracting. You all are going to now, hopefully, go ahead and do the independent practice. Remember that we have the solutions already up on Canvas, so you can go ahead and do these on your own and check your work with those in Canvas just to make sure you're doing it correctly. We're going to jump into 2-3, which is multiplying or dividing. When you're multiplying or dividing, it's pretty much the same thing as you're solving equations, but there's one additional thing that you need to take into account. I want you to consider the idea of two numbers being compared. If I gave you the number 5 and I gave you the number -7, you can compare them by saying that 5 is actually greater than -7. If I asked you to perform operations to both of them, add, subtract, multiply, or divide, let's start with adding. I can add any number, I don't know, 8. And then if I add the same to this, that's going to give me 13, that's going to give me 1, and 13 is still greater than 1. If I decide to subtract to both sides, you get 8 and you get -4, and 8 is still greater than -4. The relationship doesn't change. If I decide to multiply by 100 to both sides, you notice that that gives me 800 and -400, and 800 is still greater than -400. So the left side is still greater than the right in this example. Okay, so this is just an example. If, however, I decided to multiply by negative or divide, it doesn't really matter. Let's start with divide. If I decided to divide by -4 to both sides, 800 divided by -4 is -200, and -400 divided by -4 is +100. You notice that the relationship between the left and the right, what it actually does is flip. It's no longer greater than, it's now less than. Well, the mathematicians did this over and over and over and over and over and over again, and what they discovered was that this was always true. And so what they said is, okay, instead of people having to figure this out on their own, let's make a rule. And that rule is, when you're solving inequalities, if at the end you end up multiplying or dividing by a negative, what you need to do is you need to flip the inequality symbol. This is what I refer to as the little red flag. The little red flag says if multiplying or dividing, flip the symbol. This is important when you're solving, especially if you're multiplying or dividing. So this is an example of what I just said. They demonstrated to you how you could multiply, it stays the same. Everything stays the same. However, when you multiply or divide by a negative, the inequality direction symbol flips. That's what they're saying here. So you're welcome to look through this, but that was basically the gist of it, what I said right here. So in this case, if I am going to solve, I'm going to follow the same steps as normal. I am going to divide by 23. Notice I'm dividing by a positive, and so that's not going to do anything to the symbol. Divide by 23, divide by 23. You get m is less than or equal to, and 69 divided by 23 is 3. The symbol did not flip because you didn't divide by a negative. You go to 3 on the number line. It's a closed circle because it's or equal to, and less than shades to the left. Okay, the next one. I am multiplying a by 3/4. You're going to multiply by the reciprocal, which is 4/3. Whatever you do to one side, you do to the other. Remember, the whole number's over 1. I know you're thinking of something, but give me a second. A, here, you are multiplying by 4/3, which is positive. Yes, you're multiplying to a negative. You're not multiplying by a negative. And so you're not going to flip the inequality symbol. It stays the same. And when you multiply fractions, remember you're allowed to cross divide. So 3 goes into itself once, and 6 divided by 3, -6 divided by 3 is -2. And then you multiply the numerators. -2 times 4 is -8 over 1, which is just -8. So you go to -8. It's a closed circle because it's greater than or equal to, and greater than shades to the left. if I was to write this in set builder notation, the one above, I would say the values of m such that m is less than or equal to 3. The values of a such that a is greater than or equal to -8. So that is the way to write these solutions. Okay, let's look at this one. In order to solve for this one, I need to divide by -3. Divide by -3. Little red flag, you're dividing by a negative. Why? And now your greater than symbol becomes is less than, and -45 divided by -3 is +15. So now your inequality solution is that y is less than 15. So you go to your inequality graph. Y is less than 15. Well, 15 is right here between 14 and 16. It's an open circle because it's not or equal, and less than shades to the left. Set builder notation, all of the values of y such that y is less than 15. Close set builder. So you might want to make that darker so that it makes more sense. Okay. Next one. You are a negative. You're dividing by 6. This here, recall from previous lessons that this is the same thing as either -a/6 or a/-6. They are all the same. I recommend that you look at it in terms of the last one. Look at it so that the denominator has the negative. Because then what happens is when you rewrite it, you notice that a is being divided by -6, and that leaves it so that it is greater than or equal to 3. And so when you go to solve, you're going to realize you have to multiply by -6 to undo that. And when you multiply by a negative, little red flag, flip the symbol. And you get a is now less than or equal to, and 3 times -6 is -18. -18 is here. It's or equal to, so it's shaded in, extra ink underneath. And less than means you shade to the left. Set builder notation, all the values of a such that a is less than or equal to -18. Close set builder. So that is basically these. Let's do one more, and then you're going to do the independent practice. Check your work on the solutions that we have up on Canvas, and then you're going to do math space. Okay, let's look at this question. Again, it's a word problem, so initially our instinct is to get frustrated and to think we don't understand it, but just read it to give yourself the story first before you go forth. I'll give you a little bit of insight. When I was doing this question right now, I just had to pause and restart. So what you're hearing right now is the second version of me trying this question because I overthought it. So it happens to all of us. Just read it and try to understand it. First, a cookie recipe calls for 3/4 of a cup of sugar for a cookie recipe. Okay, so we're picturing in our head the fact that in order to make cookies, you need 3/4 of a cup. The cafeteria cooks have 9 cups of sugar. That means they don't have anything more than that. They have no more than 9 cups of sugar. If the recipe calls for 3/4 cups for one batch, per batch, then I know that the total number of batches that they are going to be able to make, how many batches will they make, is what they're asking. The total number of batches is going to be 3/4 of a cup multiplied by the number of batches, and that is going to be no more than, which means it's less than or equal to, 9 cups of sugar. To solve the equation, we are going to remember the inequality. Sorry, I said equation and it should be inequality. You're going to undo what's being done. You're multiplying by a fraction, so to undo it, you multiply by the reciprocal. There's no negatives involved, so there's no flipping. B must be less than or equal to, and then I follow my steps of multiplication again. 3 divided by 3 is 1. 9 divided by 3 is 3. 3 times 4 is 12. 1 times 1 is 1. So B is less than or equal to 12. They can make no more than 12 batches of cookies. That's how many batches they can make. So what you all are going to be working on now, the next step in the process, would be to follow ahead and complete the next independent practice questions. Remember that the answers are on Canvas so that you could check your work, but you are expected to do this on your own in your notes. This is independent, so I'm not going to go ahead and record the answers even though the answers are already up for you to check your work. Same thing with these questions. Please make sure that you complete those as part of the independent practice, as well as these. So you have 13 independence practice questions that you should continue and complete in order to make sure that you understand them properly. With the word problems, this is also part of the independent practice. There's 4 questions. Make sure that you write the inequality and solve it. And once more, even though I said this already, the answers to all of this, the completed answers, are on Canvas. They will be on Canvas by Thursday, which is the 26th, so you can check your answers. The 2.2, 2.3 math space, it's 1 math space. You will be working on it Friday. So you are going to make sure that you complete the independent practice so that you understand how to do this. But the math space is going to be, you're going to be working on it on Friday in class. It will be due Monday. And Monday is October 1st. Wow, it's already October. Please email me if you have any questions whatsoever, or ask me tomorrow, and I will see you then. Bye.